Over these. So it says line T is tangent to the circle. Find the indicated measure. So what would be the measure of the arc AB? What would be the measure of the arc AB? Now, you have to be careful, guys. The notation is very important. What would be the measure of the arc AB? Any ideas? Andrew? Well, we're only given one piece of information. Do you guys agree? Yeah, we're given this angle down here. It's 101 degrees. Can we help that with finding anything else? Does that help us with anything? Yeah.
Well, you know that the other side has got to be 89 degrees.
89 degrees? 79 degrees. Very good. Why does this side have to be 79 degrees? Yeah. They must add up to 180. Very good. They're a linear pair. Do you guys agree with that? So now, AB, guys, yes, please. Thank you, Alexa. AB has to be this side of the circle. Why does AB have to be that arc and not the other arc? Why does AB have to be this arc and not the other one on the other side? Lauren? Very good. How did you know it was a minor arc? No. Blair? Correct. Guys, only minor arcs can use two letters to identify them. So I know you guys are like, but C is a point over on that arc. I know. But you guys, if they say AB, it has to be the smaller of the two arcs, okay? If they said ACB, then you know it would have to be the left side. But they would have to have another point here and say it was ADB, for example, to show you that it was the other side of the arc. So now we know that the left-hand angle is 79 degrees, but that is not the measure of that arc. How do I find the measure of the arc? Pedro? You multiply it by 2. So we multiply the 79 by 2. What's the measure of the arc AB? What? 158 degrees. So it's 158 degrees. Camilla? You can multiply 101 by 2, right? You would get 202 degrees, and then you could go ahead and subtract that 202 from 360. The cool part about these problems, guys, is because there's so much symmetry, you can actually do any of these problems one of two ways. You can do it using the angles, adding up to 180, or you can use it using the circle, the arcs adding up to 360. Chloe? Yep, because it used two letters, it has to be a minor arc, correct? So because it's a minor arc, it has to be the smaller of the two sides, right? You already knew this angle was 101, so that's definitely greater than 90. That's more than half the circle. Do you agree? Or more than half the line. So this is going to be the larger arc, more than a half of the arc, which would be 180. So the arc that's less than that, the minor arc, would be the 158. Good question. What other questions do we have on this first example? Okay, the second example says FH. Again, must be what kind of arc? Minor. So FH, the minor arc, do you guys see how it's that piece right there? How do I find the measure of that piece right there? The measure of that arc. Gigi? Very good. Let's start with doing 180 minus 129. What does that give me? 51 degrees. So that means what is now 51 degrees? The angle. Very good. So the angle over here is 51 degrees. But how do I figure out the arc given that angle? How do I find the measure of that arc given that angle? Sophia? Excellent. We just multiply it by 2. 51 times 2 gives me 102 degrees. So this would have to be 102 degrees. Talk to me. What questions do we have? Andrew?
I understood it in class, but then like when it came to the homework, it didn't really make sense.
Yep, we're going to go over the homework. So I'm glad that you said that. Okay. All right. Number 3, the measure of angle 1. What can I do here? Shayla? Yes, perfect. 360 minus 248. Why did you do that, Shayla? Excellent. The outside of the circle, the degrees is 360. What did you get when you subtracted it? 112. Excellent. Now we're going to divide by 2 to get us into this angle because the arc here is 112. The angle must be 56 degrees. Excellent. 56 degrees. Make sure you put a degree symbol on all 3 of your answers because we're talking about the measure of an angle or an arc. And what questions do we have on any of these 3 examples? All right, next thing we're going to do is take out your homework. Guys, we're going to learn about segment relationships in circles. So our chords are going to be like split. They're not going to be full chords. They're going to be cut. Our secants are going to be cut. And we're also going to look at tangents, okay? So each of these segments, it's going to be pieces of a line. And it's very, very important that you pay attention to the pieces that I'm talking about. For example, what piece of a chord, what piece of a secant I'm talking about, okay? The first one we're going to learn about is a vocab word called segments of a chord, okay? The segments of chords are when 2 chords intersect in the interior of a circle. Each chord is divided into 2 segments called the segments of the chord, okay? Now, it's very important that you do not mix and match these, okay? So let's go ahead and group them together. CE is a segment of which chord? CD. What is the other segment of the chord CD? And which one? DE, very good, or ED. Both of those would be grouped together because they are both part of the same chord. Do you guys see that? What are the other 2 segments that are part of the other chord? AE and EB, okay? It is very important, guys, that you guys do not mix and match these, okay? If it belongs to one chord, you're going to keep them together. Because when we apply the next theorem, it's super important because we're going to be multiplying these values by each other, that you keep these segments with the same chord. All right, so our first theorem today is the segments of chords theorem. If 2 chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord has to be from one chord, is equal to the product of the lengths of the segments of the other chord. So, the 2 segments that we're looking at in our example, we would multiply EA times EB, and that would be the same as multiplying EC by ED. Okay? So as long as you're multiplying both segments together of the same chord and those 2 chords intersect, they will be equivalent. And let's go ahead, let's do a quick little example for ourselves. I would like you on this diagram to make AE 4 units. Let's make EB 5 units. Let's make DE 2 units, and let's make EC an X amount, an unknown amount. All right, so what 2 values, God bless you, should I multiply together? It's the 2 segments of the same chord. Veronica? 4 and 5, very good. So 4 times, whoops, you can't see that, can you? Is this better? 4 times 5 equals, what other 2 values am I multiplying together? 2 and X, because they're part of the same chord. Do you guys see that? Do not mix and match. I see it happen all the time where they multiply 4 and 2 together and X and 5. That's wrong, okay? You multiply the 2 segments that are part of the same chord. So now we go ahead and solve this. What's 4 times 5? 20 equals 2X. What do I do next? Divide by 2. X equals x equals 10. Simple? Cool. Any questions on this first example? Could you see yourself, maybe, if you're in a rush, multiplying the wrong numbers together? Okay, make a note of that if you could see your mistake already, okay? All right, let's do a few more examples, or two more examples really quick. What would I do here in this first example? You guys have this slide or no? Yes? Okay. What would I do in this first example? Three times x, good. Set it equal to 4 times 6, okay? All right, 3x is just going to be 3x. What's 4 times 6? 24. We divide both sides by 3. X is equal to 8. That's it. Cool? Questions? All right, moving on to number 2. What would I do in number 2?
2 times x plus 1.
2 times x plus 1. Guys, why is it very important that I put parentheses around the x plus 1?
Because you got to distribute.
I'm going to end up distributing. Very good. Equals?
Equals 4 times 3.
4 times 3, which is 12, right? Distribute the 2. It's going to be 2x plus 2 equals 12. Subtract 2 from both sides, you get 2x equals 10, and then divide by 2, x equals 5. Would it be okay? I saw some of us do this actually. Would it be okay if I just divided by 2 at this point to both sides? Am I allowed to do that? Yeah, sure am. Okay. If I did that, I would get x plus 1 equals 6. You subtract 1 from both sides, right? Minus 1, x equals 5. Okay, we get the same answer regardless. Whatever method you are most comfortable with, feel free to use that one, okay? I just love to distribute, so as soon as I see to distribute, I just go for it, okay? But if you want to divide by 2 to both sides, go for it. What questions do we have on this example? All right, love that for us. Let's move on. Next, we're going to learn about a secant segment. A secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. The part of a secant that is outside the circle is called an external secant, or an external segment, excuse me. So by definition, do you guys remember what was a secant before? Yeah, Gabby? Very good. It goes through the circle. It continues outside the circle. Do you guys agree? A secant segment is also continuing outside the circle, but it stops. This segment stops at the edge of the circle. Do you guys agree? And somewhere where it meets up with another segment. Cool? There becomes 2 parts. The external, which is in red. Do you guys see that part? And the internal portion. Agreed? Now, a tangent segment, this blue one, does it have an internal portion? Does it ever go inside the circle? No. So tangents are a little bit different. A tangent segment, and this is on the next slide, is a segment that is tangent to a circle at an endpoint. So tangents do not actually go inside the circle. It's just going to touch the circle, like graze it just a little bit, and then it's going to stop at that point. Okay? What questions do we have about a secant segment and a tangent segment? Okay. So the theorem 10.19 says that segments of secant's theorem. It says if 2 secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So as long as these 2 secant segments are in the same circle, you can apply the formula which says you take the whole thing, you multiply it by just the external part, and that should be the same value as the whole thing times the external part for the other secant, okay? Now, let's apply that. The whole length of this segment, do you guys agree, would be from L to N, correct? But what's just the external part that's outside the circle? From M to N, okay? I recommend that you guys draw little blocks like I am so you guys can see how they're being sectioned off. Then on the bottom, we're multiplying from P all the way to where? N times the external part. What's the external part of that segment? From O to N. Now, this one and the chord theorem that we just learned about, a lot of you guys get confused because when these values are filled in, a lot of us are just going to take LM and we're going to multiply it by MN. But remember, it's the whole thing times the external part. So you have to add these together first and then multiply it by the exterior part, okay? All right. We're also going to see segments of secants and tangents theorem, okay? So by the same logic, right, a tangent never actually goes inside the circle. So when you talk about the whole times the external for a tangent, it's going to be the same value. So tangents just become squared when you compare them to secants, okay? So that value LM, it's the whole thing, and it's also being used as just the external part. So we basically multiply it by itself, so it gets squared. Okay? I'm sure some questions will come up when we're doing. Sure. Let me know when you're done, Aurora. You guys can start working on the first example. Yeah, Tyler. Say it one more time. To the first slide. Yeah, I'll go back at the very end. I'm good? Examples. That's all the learning we're doing today. The rest of it's just application. Please, please, please cross out number 4. We are not going to do that. If you want to try it, you're going to get a quadratic. You'd have to solve a quadratic to do number 4. I promise I will not give you a quadratic on your assessment. Yeah. The last slide? Okay. So for this first example, help me set it up. What am I going to do? 3 times x, good, equals 12 times 2, which is 24. So we have 3x.
Interruption. At this time, we ask that all seniors go to the gym. Please bring your belongings with you. Again, all seniors, which should report to the gym at this time. Please bring your belongings with you. Thank you.
So we should have gotten x equals 8 once we divided by 3. What questions do we have on the first example? Hey now, were those chords or were those secants in the first example? Those were chords. Remember, it's going to be 2 different processes whether they're chords or secants. Check out letter B, chords or secants? These are secants with actually one that is a tangent. Very good. So let's try to set up letter B. This secant, what's the measure of the whole thing? It's not 18. It's 24. How did you get 24, Jasmine? You add 18 and 6. What's the measure of the external part? That's 6 units. What do we do with those 2 values? You multiply them. So 24 times 6 is going to be the same. What do I do with the tangent, though? You square it. So you take the x value, because remember, the tangent is both at the external part and the whole thing. Do you guys agree? So we're using x twice, so that'll be x squared. What is 24 times 6? I got 144. 144 equals x squared. How do I solve this from here? Take the square root. Good job, Bella. And the square root of 144? 12. X is 12. Talk to me. What questions do we have on this example? Gigi. 24 times 6. Why are we doing that? Okay. Remember, the formula says the whole thing times the external for secants. What is the measure of the whole thing? 24. What's the measure of just the part outside the circle? 6. That's where we multiply them together. For the tangent, we're still using the same formula. What's the whole thing from here to here? X. What's just the external part? X. What's x times x? X squared. Okay? Good question. What other questions do we have? All right, moving on. Let's do number 3. Are one of them a tangent or are they both secants? They're both secant segments, okay? So what do I do? Don't say 9 times 6. Ooh. Don't say 9 times 6. What is it, Andrew? What? 9 times 5 is also wrong. Yeah. 9 plus 6 times 6. Which we should know what 9 plus 6 is. What is it? So let's erase it. Let's put 15 there. Where are we getting 15 from? You're adding 9 plus 6. Remember, the whole thing times the external part. It's just 15 times 6 equals x plus 5, good, times 5. What am I going to have to do on the right-hand side, people? What does that 5 have to do? Distribute. Excellent. So let's distribute it. It's going to be 15 times 6. I believe that's 90. Equals 5x plus 25. What do I do next? Huh? Who said that? You were right. What'd you say? Good, Lauren. What'd you say? Subtract 25. Very good. What do you get? 65 equals 5x. Then what? Divide by 5x is going to be equal to 13. How we doing? How many of us could see ourselves making a mistake like multiplying 9 and 6 together? I do it too, guys. It happens, okay? Just learn from whatever mistakes you make. Blair, you had a question?
I was going to ask why you multiply by 5 because you're not on but there wasn't like any other number last time. But so I get it.
You got it now?
Yeah.
Okay. All right, let's do another 2 examples. Guys, please, 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 if you don't do this, you're going to be confused. Cross out D. You're also going to get a quadratic there. If you want to try them, feel free. By all means, go for it. Extra math, fun, practice. But you do not have to do them, okay? You don't need to know how to do it when it creates a quadratic, all right? Letter C. How would I set it up for letter C? Gigi? Yes, 12 times 4. Very good. 6 plus x times 6. Nice job, Gigi. All right, someone walk me through solving this. What do I do? Andrew.
Distribute 6. 36 times plus 6x. And then on the other side, you can do 12 times 4, which is 48. Then subtract 36 from both sides, which is 12. Then you divide by 6 and you get x equals 2.
X equals 2. That's it. Now, could you see Mr. Jericho asking you maybe to find like the measure of the entire bottom secant?
Yes.
Is its entire measure 2? No. What would you have to do?
2 plus x.
We'll do 2 plus 6, which is 8. So the entire bottom secant is 8. Okay? Do those secants necessarily have to be the same length? No. Okay? Just their proportion of multiplying the whole times the external and the whole times the external, that's going to be the same ratio. Okay? All right. Let's do one more. Let's do this one. CB is a secant or a tangent? Tangent, because it only has an external part. What do we do with tangents in our formula? 20 times 20, so it'd be squared, 20 squared, equals, is that bottom one a secant or a tangent? That's a secant. What's the whole thing? 8 plus r, no, not squared, plus r. It's going to be 2r. Very good. And we're multiplying that by what? The external part. Whole times external. What's the external part? 8. Very good. Let's clean this up a bit. We know what 20 squared is. What's 20 squared? What's 20 squared? 400, thank you. Equals, let's clean this up. What is r plus r? We said it already. It should be 8 plus 2r times 8. I'm going to do this one a little bit differently. You can absolutely distribute. But for all you divider people that like to divide, let's do this one by dividing. At this point, we could divide both sides by what? 8 instead of distributing. So if we divide both sides by 8, don't make fun of me. I don't know what 400 divided by 8 is. Is it 5? 50? Yes. Yes, it's 50. So 50 equals 8 plus 2r. Subtract 8 from both sides. You get 42 equals 2r. Divide by 2. R equals 21. Blackjack. All right. Talk to me. What questions do we have so far? Yes. Go ahead.
Theorems?
Theorems for the test.